Bismillahirrahmanirrahim. Welcome to the next lecture of computer architecture. Today I'm trying to uh, revise the cache mapping functions and the basic definitions because this is very important uh, in the exam point of view, and you will need it in different tests and exams. And moreover, there are two international students and they have requested me. So these topics will be included in the final uh, term as well. So in today we have three different videos. So we will in first video we will define these basic terms of the cache. In the second video and third video we will talk about direct mapping, associative mapping, and set. Okay, so what is the cache? Cache is the fastest memory placed between the main memory. This is RAM. Main memory is the RAM, and the next access memory, the main memory, and the processor. This is processor. So cache is placed between these two memories. This is fastest than main memory. So during processing, the words are transferred here in the cache, and the CPU directly access from the cache. But in memory, the words are stored one by one, but it goes more than one words. So more than one word is called block. Block contains one or two or three or four words, which goes from main memory to the cache. Then from cache to CPU or central processing unit, it goes word by word. Okay, this is the main diagram. Suppose we have the main memory with 2 raised to the power n words. Suppose this is 16. So 2 raised to the power 4 is equal to 16. So here n is 4. So it starts from 0 to 2 raised to the power n minus 1. So in case of 16, it will start from 0 and will reach to 15. Okay. Here this is cache memory. It also starts from 0 and raised to the power c minus 1. C is the total number of lines in the cache. Usually the number of cache lines are much smaller than the total number of lines in the main memory. And this one line contains more than one word. A bunch of words is called block. So for example, if this contains one cache line can occupy 6 words, so the 6 words are blocked into a single block. If it contains 2 words, how much words this one line can contain is called block size. For example, if it contains 2 words, so each of these 2 words are grouped into single block. This is another block, and so on so forth. So what is block? Then here we in main memory we just merge 2 or more than 2 words depending upon the cache length width. How much words a cache can occupy each line is called block length. So the cache is, for example, this is 16 words. If the word size is 2, so these 16 is divided by 2. So total 8 blocks are in the main memory. Okay. And this is the basic flowchart of the cache operation. Generally from CPU, if it starts, see address from CPU, it first checks is block containing this address is in cache. If the block is found in the cache, this is called cache hit. So the word is fetched and delivered to the CPU and finished. So what is cache hit? If CPU requests a block and finds it in the cache, this is called cache hit. But in case if the block containing this address is not in the cache, no, it's not found in the cache. So this is called cache miss. This is miss and this one is hit. So this is the basic definition of cache hit and cache miss. So if the block is not in the cache, so what is done? The access main memory for the block. The, the block is brought from the main memory. Allocate cache line for the main memory block. So the block came from main memory to the cache, so cache line is allocated. If there exists some data on the respective cache line, it is replaced using a replacement algorithm. Then deliver two tasks are done. Deliver the word to the CPU because this word has been asked by the processor, so it is given to the processor and load the main memory block into cache, and it is also loaded to cache for the future use. So this all this is called cache miss and this is called cache hit. Now the process, when a cache miss occurs, this whole process takes some time, which is called miss penalty. So this is difference between cache miss and miss penalty. The time required to handle a cache miss, which includes loading from main memory to cache and from cache to the CPU. Okay, so there are the basic definition. Cache hit when the data is found in the cache, it is called cache hit. When the data is not found in the cache, it is called cache miss. Hit rate, the total, the percentage time of data is found in a given memory block. For example, in last few seconds, we did 10 operations, total operation 10, 8 are cache hit and 2 are cache miss. So 8 divided by total 10, 8 divided by 10, 0 0.8. 0 0.8 is cache hit, hit rate, sorry. This is hit rate, and total number of operations are 8, total number of hits are 8, and total number of miss are 2. The rate at which the percentage time is not the percentage rate of cache misses is called miss rate. Now miss rate can be calculated 1 minus hit. This is hit, so 1 minus hit is equal to 0.2. This is cache miss. Okay, this one is a little change. Miss penalty, as I defined in the previous slide. This is the total time required to handle a cache miss. Beside this is access time, the time between presenting an address and getting a valid data. When CPU requests uh, some data, it gives the address and gets the time it spends in requesting and getting the data is called access time. So access time of the cache is shorter. I mean, it's quick. And longer access time means slow. Okay, the next one is memory cycle time. It is just the access time plus recovery time. After the accessing some data, the memory needs to be recovered. So the total time required in handling this one of instruction is called memory cycle time, which includes access time plus the memory recovery time. And the rate at which data is transferred is called transfer rates. Okay, and the next important topics are mapping functions and replacement algorithm, which we will study in the next slides.